Hello friends, welcome to yet another tutorial on the Pixlpal firmware series. In this tutorial, we'll be talking about the Pixlpal application layout. We will discuss this by briefly exploring an example, after which we'll go ahead to demonstrate the app layout by creating a template app. The template app can be used as a basis for developing a new application by simply just changing some parameters like the name of the app and uh, storage location. As you can see on display is an app running on the Pixlpal. It's actually an example app which is named Draw Shapes. This example shows how different shapes can be drawn, as can be seen on screen. To demonstrate our template app, we'll do similar by launching the app right from the main function. After successfully initializing the Pixlpal, the function or the app rather will be launched immediately. That is the template app we'll be creating. This current program launches the example draw shape apps. That's why we have it on here. I'll just quickly go ahead and restart the device so you see the Pixlpal execute it. You can see the logs after initialization. The Pixlpal, or rather the example draw shapes app, is executed immediately. Upon execution, the program goes into a loop showing the amount of free internal RAM. We'll discuss on this later on. It's not compulsory, it's just a means of monitoring the system. The free internal RAM is printed every 30 seconds. We'll revisit this. So we'll dive right into it. You can see we have about 78 kilobytes. Moving on, using the example draw shape app as an example, we'll briefly discuss the application layout. So typically, every Pixlpal app is an expressive IDF component, and we have all apps saved here in this folder. We'll use this folder to save example apps as well as the template app. Opening the draw shape apps, which we can find in here, we can find I think two files: the example draw shapes app.cpp as well as the CMake list. We'll discuss both on these. These include folder. It depends, you make use of it depending on how large or complex your application is. It's not absolutely necessary to have it, but for the purpose of demonstration, we would include it in this example. So I can open the draw shape app example by clicking on the file, or better still, I can write from using the variable. I simply click and go to definition, which will automatically open the file showing me where the example draw shape app was defined. Now, this particular application, as I mentioned, simply just demonstrates how shapes are drawn. However, it has all the layout or elements of a typical Pixlpal app. Starting off, there are two key files you have to include, two key header files for those familiar with C and C++, which is the Arduino core, as well as the Metabit engine header. These header files contain the definitions of function APIs you need while developing applications. There are others, such as this for drawing graphics. This particular application draws basic graphics. That's why we have these header files. Depending on what you need, USB functionality, MQTT, and the likes, you include the relevant header files. As was mentioned, each application, the implementation of each application is actually a FreeRTOS task. So a FreeRTOS task is expected to have a task handle. So we'll go ahead and define the task handle, then the task function, which follows this template. The parameter is a void pointer. We don't dwell so much on this. Moving on, we go ahead and define or create the example drawship, which is an object, a C or C++ object. However, to initialize the object, we use the FreeRTOS task create wrapper, which we have here. I'll go ahead and expand this so you can see. Okay. Now, I would mention at the onset the purpose of this macro, external RAM BSS attribute. What this does is it places this particular variable in the external PSRAM of the ESP32 SoC, which is what we are using in the Pixlpal. External variables such as when you use this macro, when you precede a variable with this macro, it places the memory of that variable is placed within the external PSRAM. This is done to save the internal PSRAM. Save as much RAM as you can for the purpose of the application. Or while application executes, internal PSRAM is much more faster. So there are certain scenarios where you need very fast executing memory. That's why whatever doesn't need to execute very fast or occupy space within internal RAM is moved onto the external RAM. So this application and all its memory, after being created, is placed within the external RAM. This is done only for variables. Functions does not need to carry this macro. Moving on, you go ahead and define the application. Upon defining the application, you cast the parameter. That's the void pointer parameter, which we have here. You cast it into a Metabit application. We'll demonstrate this when we create the template app. Mind you, the template app, it wouldn't do anything special. Rather, it would just print on the console at regular time interval. We'll use the opportunity to introduce debugging within the Pixlpal or ESP-IDF environment. How to debug by printing text to the console. Moving on, after casting, you go ahead and initialize the app. Upon initialization, another key parameter, these are basically APIs for drawing graphics onto the screen, which is peculiar to this particular Drawships app. So we'll come back to this later on when we describe how to draw shapes. Another key item of an application is it goes into a loop. Just as most microcontrollers function or operate, you have a loop where your program runs continuously in a circle. A similar approach is used for Pixlpal applications. However, this particular loop carries a condition which can be seen. I would explain why this condition is used for the loop within an application. The condition remains true while the application is allowed to run and becomes false based on external event, which causes the application to exit. And then finally, you clean up the application resources before exiting the application. We'll go ahead and create the template app. However, this video appears to be a bit above 10 minutes. I think 11.8 minutes already. Would go ahead and make a different video for the template app right after this one to keep the videos as short as possible. So thank you once again for listening. In the next video tutorial, we'll dive right into creating the templates application.